Okay, I'm going to go over our guided notes for factoring trinomials when we have a coefficient that is not 1, and I'm just going to do some select problems so that it's not quite such a long video. You can read along with your notes, but before we were using a coefficient of our leading term of 1, and now we have a coefficient of 2, so this is going to be our first example. When we have a coefficient that's not 1, we're going to use something called the box method to solve, to find our factors that are binomials. Okay, so first we're going to find the product of A and C. Okay, in order to find the product of A and C, we need to find A. A is 2, and B is 11, and C is 5. A times C then is 10. Okay, so I'm going to use that information and I'm going to put it all in a box. I need the factors of A times C. And once I find factors of A times C, I want to figure out which of those factors will give me a sum of B, meaning which of those factors will add up to equal B. Okay, and then I'm going to fill in this fancy little box, and I will pull out the greatest common factor, that again, yes, and always my answer is going to be to write all of my terms that I pull out as 2 binomials. So that's a lot of information. Let me slide my paper up, and we're going to fill in our box and use the box method to solve this problem. Okay, here's what we're going to put into our box. I need the first term, which is ax squared. So that is right here, 2x squared. And right now, I also already know my c. Ax squared plus bx plus c. My c is 5. I need to find the 2 bx terms. So that's our goal. To find those bx terms, I need to take a times c and find the factors. So a times c is 10. So what are my possible factors of 10? 1 times 10, 2 times 5. Those are my factors of 10. I need to find factors of 10 that equal 11, my b value. So that's obviously going to be my 1 times 10 set of factors. Okay, so now I'm just going to plug those in as b. I have 1x, or just x, and I have 10x. It doesn't matter whether I put the 1x here or whether I put the 1x there. It doesn't matter. It'll work out the same. Okay, so now that I've done that, I need to pull out greatest common factors. I am right here at step 5. Vertically and horizontally pull out the greatest common factors. Vertically, my greatest common factor here is 2x. My pen's not working. And vertically here, the only thing that I have in common is 1. I can divide each of those by 1, and that's it. Okay, so now horizontally, I'm going to pull an x from 2x squared, and I'm going to pull an x from x, and I'm going to pull 5 from each of those. Okay, now, what I'm going to look at are these terms that I just pulled out. I need to write a binomial as my answer, so I'm going to have 2x plus 1 times x plus 5. Okay, 2x plus 1 from there, and x plus 5 from there. Again, it does not matter. If I wrote x plus 5 times 2x plus 1, it would be the same. So, let's prove it to ourselves. Let's multiply. We are checking our work. So if I use FOIL, I get 2x squared plus 10x plus 1x plus 5. And I'm going to combine like terms. 2x squared plus 11x plus 5. And let's look back at my original problem. 2x squared plus 11x plus 5. Yay, it worked. So my answer that I would turn in is that set of binomials that I'm going to multiply together. Okay, so like I said, I'm only going to do select problems, but I just want to remind you, anytime I'm solving information that I want in my box method, I need to remember that my box will have ax squared and bx and bx and c. Please remember that that is a c. That is not a times c. So I can fill out what I know already. A is 2, b is negative 3, c is negative 20. So a times c is negative 40. I can fill in what I know in my box. Ax squared is going to be 2x squared. I don't know my bx's yet, but I do know that c is negative 20. Again, be super careful that you're putting c there and not a times c. Okay, so my next step is to figure out what are my factors of a times c. So if I have negative 40, I know that one of the factors has to be negative. For right now, I'm just going to write all of the positive factors, and then I'm going to realize that one has to be negative when I find the sum. Okay, so to get negative 40, one of these has to be negative. It's going to be 1 times 40, or 2 times 20, 4 times 10, 8 times 5. Now what I mean is negative 1 times 40 is negative 40, or 1 times negative 40 is negative 40. So if I have that in mind, and I figure how am I going to get a sum of negative 3, I'm going to look right here, 8 and 5, that's going to do it. If I have negative 8 times 5, that's going to give me negative 40. And when I add negative 8 and 5, I will have negative 3. So now I know my values for bx. I have negative 8x and I have 5x. Okay, I need to factor out. So if I factor vertically right here, the only thing I can pull is an x. It's positive x because this coefficient is positive. Here I have negative 8x and negative 20. I'm going to pull out negative 4. It's a negative number because this coefficient is negative. Okay, so I can take negative 4 from negative 8x and I can take negative 4 from negative 20. When I look at this information here, I'm going to take 2x from each of those. 2x. It's positive again because that first coefficient is positive. Here, I can take 5 out of both of these, so I'm going to just take positive 5. And now I'm going to look at my two binomial terms. I will have 2x plus 5 times x minus 4. When I check my work, 2x squared minus 8x plus 5x minus 20. Combine like terms, 2x squared minus 3x minus 20. Let's take a look. I got that right, so check. So the answer I would turn in is that guy right there. Okay, I'll do 3 more problems from these notes. I'm going to do problem number 4 right now. So looking at problem number 4, I need a equals 3, b equals 14, c equals 15, and a times c equals 45. I'm going to make myself a box. And I already know ax squared is 3x squared, and I know c is 15. So the next steps are to figure out what are my factors of a times c, of 45. Luckily, everything up here is positive, so I get to use just positive numbers here. So 45 breaks into 1 times 45, 3 times 15, 5 times 9. So I'm going to stop here and look and see, are any of these factors things that I can add together to get 14? Yep, 5 and 9 are. So I'm going to put 5x and 9x. Now I'm going to factor out. When I factor out, vertically I can take 3x out of here. Vertically I can take 5 out of here. From those guys, horizontally I can take an x, and from these guys I can take a 3. So my binomial will be 3x plus 5 times x plus 3, and I get 3x squared plus 9x plus 5x is 14x plus 15. And I want to come look back up here, and that is what I expected to get. Great. Every once in a while you'll find a situation where there is simply no answer. So we're going to look at number 2 in your notes and set it up the same way we have. A equals 5, b equals negative 7, c equals 3. A times c equals 15. I make my box. I know that I have 5x squared, and I know c is 3. Okay, so now I need to find things that are going to multiply together to give me 15, but they're going to add up to be negative 7. So the only way I can have a product that's positive and a sum that's negative is if every factor that I'm multiplying is negative. So I'll say negative 1 times negative 15, negative 3 times negative 5. I don't have any other options. So now I'm looking for which of these factors is going to add up to give me negative 7. Well, this gives me negative 16, and this gives me negative 8. I do not have any options that will give me negative 7. So, what that means is there is no way for me to factor this out. If that's truly the case, you're going to write prime as your answer. It's already prime. There's no way to factor it any further. Okay, finally, I want you to look at number 4 on your notes. Number 4 on your notes. I want to see, is there a greatest common factor that I can take out of each of these? There's actually not, so just kidding. Let's look at number 3 on your notes. I want to always look to see if there's a greatest common factor that I can pull out. So 3x squared minus 12x plus 12. If you just were looking for GCF, you're going to pull 3 out of everything. So this problem can be rewritten as 3 times x squared minus 4x plus 4. Right? Okay, so now I'm just going to factor out that trinomial and write whatever my binomials are next to this 3. It's going to be 3 times whatever my 2 binomials are. Okay, so if I were to do this with the box method, I would have 3x squared, and I would have 12. A times C is 36. So I know that I need to have 2 negative numbers to get a negative b. So I'm going to have negative 1 times negative 36, or I might have negative 2 times negative 18. That doesn't give me negative 12. I might have negative 3 times negative 12. That doesn't give me negative 12. Negative 4 times negative 9. Negative 6 times negative 6. There it is. So I'm going to use those 2 terms inside. So